Hello, my name is Walter Unglaub, and this is What is an equation for displacement and distance in physics? So before we begin, it's important to note that there is a fundamental difference between what we mean when we say displacement and what we mean when we say distance. Displacement is actually a vector quantity, technically speaking, although oftentimes we just care about the magnitude of the vector, d, I'll call it, and distance is a scalar quantity, meaning that it's just a number. And I'll use lowercase d to denote distance. So here I have an example in 2 dimensions where I have an initial position denoted by the point s sub I, and it has coordinates 1, 4, and then I have a final point for my journey. My destination is denoted by point s sub f, and it has coordinates 1, 1. So my trajectory will be from this point to this point to this point, and then finally to my destination. And I'm going to use this example to demonstrate the differences between displacement and distance. So going from SI, my initial point, to my final point, I can draw an arrow, and this arrow has a magnitude and it also has a direction, so it is a vector. From this point I go down to this third point, and again I have another vector, and finally from that third point I reach my destination via this third arrow. So if I wanted to calculate the distance, all I have to do is sum up the magnitudes of the 3 arrows. It represents the total distance that I traveled from the initial point all the way to the final point. So an equation for distance then, formally, I could write d is equal to the integral from the initial point to the final point, and I'm integrating a function with respect to the dummy variable s prime. In this case, such an integral isn't necessarily needed since these functions are well defined. We can actually just read off what the magnitudes are if we know these coordinates. So in this case, I have a coordinate 5, 4, and then here 5, 1 for the second and third intermediary points. So from here to here, I have a total of 4 units of distance, and then from 4 down to 1, the difference is 3, so that's my magnitude for this arrow, and finally I have a magnitude of 4 for this final arrow. So the distance then is simply going to be the sum from I equals 1 to the total number of arrows, in this case it's 3, of the magnitudes of these different vectors. So this is equal to 4 plus 3 plus 4, which is equal to 11. And if my units are in meters, my total distance is 11 meters. Displacement, however, will be equal to the sum of the actual vectors. And then if I want to calculate the magnitude of the displacement, I have to take the magnitude of the sum of the vectors, not the sum of the magnitudes. So that's essentially the crucial distance between the essential difference between distance and displacement. So here I'm going to be moving to the right, so I have my first vector is 4 plus 4i, this is the unit vector for the x direction, plus my second vector, which is in the -3 in the j direction. So I have minus 3j, and then plus, I'm moving to the left, so I'm moving in the negative x direction, so I have minus 4i. These two cancel out, so I'm left with negative 3j as my resultant displacement vector. meaning I'm just going from the initial point to the final point if I just translate that vector. And the magnitude of this displacement vector is just the magnitude of negative 3j hat. Since j hat is just a unit vector, its magnitude is 1. And of course, I don't care about the negative for the magnitude. So I finally end up with 3 meters for the magnitude of the displacement. So in this particular trajectory, I see that the displacement is less than the distance. And these are the two different formulae that one would use to differentiate between these two measures of distance. My name is Walter Unglaub, and this is What is an Equation for Displacement and Distance in Physics?